Talk about rational functions. This is section 5 of chapter 3. So rational functions are a polynomial, or a function that has a polynomial. So these are polynomials divided by each other. So we have polynomials divided by each other, but since we are dividing, that means that q of x down here, this polynomial cannot equal 0, right? So that's gonna give us some restrictions, which we did before on we just divided rational functions, right? Where we had rational expressions, and we said what the domain was. Well, the same thing is true here, right? We got to find out what the domain is and what our restrictions can be. So first, we'll look at here are some examples. We have f of x equals 1 over x. We have f of x is x plus 1 over 2x squared plus 5x minus 3. And here's another one. 3x squared minus 3x minus 6. And whenever you do these, just like normal fractions, we normally reduce them, right? So whenever you have something squared, or any of these, we try to look for common factors that we can cancel out and reduce. Okay, so here are some examples of some rational functions. So first we want to start out looking at what we call this one right here, and that's called the reciprocal function. So we'll take a look at that one first. Okay, so here's our reciprocal function, and we're going to look on the shifts and kind of how does it move. So here's the most basic. Just like quadratic, the most basic quadratic is f of x equals x squared. Here's the most basic rational function. So let's go ahead and make a table, and let's start graphing this, right? That's the easiest way to do. We can start plugging in numbers into our equation and see what it looks like. Right? See how it changes. Okay, so we're going to plug these numbers into the function, right? So I'm plugging in -2, so I get 1 over -2. So that's -1/2. I plug in -1, that's 1 over -1, that's -1. Let me draw some lines here. I added 1/2 and -1/2 in there too. Okay, so let's plug in -1/2, so that's 1 over -1/2. Remember, when you're dividing by a fraction, that's the same as taking the numerator and multiplying it by the reciprocal of the denominator. So that'd be -2 over 1, which is -2. So this is -2. Times anything by 0, we can't do that, or times anything by 0 is fine at 0, but what about dividing by 0? That's undefined, right? So that's where we have a problem. This is undefined when we plug in 0, because we have 0 in the denominator. So that means we're not going to have an x value of 0. We can't have one. Now we plug in a positive 1/2, right? That's just going to be +2. Plug in a 1, that's going to be 1. Plug in 2, we're going to get 1/2. Okay, so then we can go ahead and graph this. Okay, so let's go ahead and graph these points. At -2, we're at -1/2. So at -2, we're at -1/2. So probably somewhere about right here. -1, -1. -1/2, -2. 0 is undefined, so we have no y value, right? +1/2, +2. 1, 1, and 2, 1/2. Okay, so as we see, and as we keep on getting bigger and bigger, as I get bigger and bigger numbers over here, 1 over 100, 1 over 1,000, these are really small numbers, right? So they get really, really close to 0, but I'm never going to get to 0. The only time I would get to 0 is if I had a 0 on top, right? But there is no x on top, so it's not going to be 0. So this is going to go down, and it's going to get closer and closer and closer to the y equals 0 here, but it's not going to cross. Same thing going this way. It's going to get closer and closer to y equals 0, but never cross. That's what we call an asymptote. So at y equals 0 here, this line right here, y equals 0, it's not going to cross. And that's a horizontal line, so that's a horizontal asymptote, so we can't cross it. There is some circumstances where we do cross horizontal asymptotes, and I'll show you how to do that later on. But let's look at our undefined part at x equals 0. So at x equals 0, we can't have that, right? We can't have 0 on bottom. So that would create a vertical asymptote. Now vertical asymptotes you cannot cross. Vertical asymptotes you can't get past it. Horizontal asymptotes sometimes will cross, just because sometimes when we have fractions like 3/6, right, we can reduce that to 1/2. Well, the same thing is true with rational functions. We can reduce them, allowing us to go ahead and plugging in numbers at our y value that we can hit because the fraction is then reduced. Okay, so as we get closer and closer, going up, right, as I do 1 over 100, right? So my fraction is 1/100th for my x. So that's really, really close to 0. So somewhere like really tiny in here, right? Somewhere really, really close to 0, but not quite 0. I flip the fraction, so that equals 100, right? So it's like way, way off the board up here, you know. So our graph's going to get closer and closer to that x equals 0, but never cross. Same thing down here when I plug in negative 1/100th, it's just going to be negative 100. So it's going to get really, really close, but never cross. And so these are what we call branches. So normally when we deal with just the reciprocal function of 1 over x, or kind of the variations that we're going to look at, they always have two branches. Okay, and usually, in most cases, all cases where it's just degree of 1 on bottom, your branches are going to be diagonal from each other. If I have, as we look at this, and as I get this function, so the most basic one, as we look at, is when we have an a up here, a over x. If that a is negative, so if you have a negative fraction, what's going to happen is that just these branches are going to flip over the x-axis. So our branches might look like this and this. Okay, so our branches would look like that. So if a is less than 0, in our kind of standard form for a reciprocal function, then it's going to flip over x-axis. Kind of just like a quadratic did. Now if a is a whole number, right, so if a is absolute value of a is bigger than 1, then it's going to stretch vertically. And stretching vertically here is a little bit different than our quadratic and stuff like that. And if the absolute value of a is between 0 and 1, then it's going to shrink vertically. Okay. So what that kind of means is basically the closest point to the origin. So ours would be right here, this closest point and this closest point. What this vertical shifting does, basically whatever a is, the closest point to the origin, if a is positive, so if a is greater than 0, then to find the two closest points on each branch would be square root a, comma square root a, and negative square root a, comma negative square root a. Now if a is negative, then it's going to be negative square root a, comma square root a, and positive square root a, negative square root a. So that's dealing with the reciprocal function, how you can find those closest points. And really all you need when you're dealing with this type of reciprocal function, so any function like this, f of x equals, say, 3 over x, or 3 over x minus 1, then we'll talk about what this minus 1 does. But the 3, all I'd have to do is just square root it, right, and estimate that point, and I can find this closest point. And once I find the closest point, I know it's going to go either up towards my vertical asymptote, or it's going to go down towards my vertical asymptote. And then it's going to go right towards my horizontal asymptote, or it's going to go left towards the horizontal asymptote. And we'll talk about that later. But really, so really all you need, even though we graphed all these points, all we need is really that closest point, or any point, just one point on each side of that vertical asymptote, and we really have this graph down. Okay, so now let's look at some of the other shifts, kind of what this -1 does. It's very similar to our quadratic and those type. So if you have a number connected with the x on the bottom, so say x minus h. Then remember how with quadratics, whatever is subtracted from x or added to x itself moves left to right. And then it's always the opposite of h, right? So it's always the opposite. Then whatever's being added to or subtracted at the end after I do my function, right? After I do this and I add something at the end or subtract something, then it moves it up and down, and it's whatever k is, right? K amount. So if k is positive, it moves up. K is negative, it moves down. So this kind of follows the same rules as quadratics and absolute value. That a is just a little bit different. It helps us find our closest point. Okay, so like that function that I did up here of the f of x is 3 over x minus 1. What this does is it moves, because the negative 1 is actually going to move it left 1. It's just going to move that vertical asymptote left 1, right? And then that closest point, if it moves it left 1, it'll be here, that vertical asymptote. Now that closest point, I can square root 3 and get a little something less than 2, because square root of 4 is 2, so square root of 3 would be a little less than that. I would go from this intersection of my asymptotes right here, horizontal one, and my vertical, and go over, 1 point something, and then go up 1 point something. Go left 1 point something, go down 1.7 something, and then I would have my closest point, and then I could go up towards the horizontal, or left towards the horizontal, down to the vertical, up to the vertical, down to the horizontal. So then I would have that graph done. So really it's, and really you can just start plotting points, right? Once we find the asymptotes, and I'll talk about that in a little bit as well. Once we find those asymptotes, we can just plot points to the left and to the right of those vertical asymptotes, and we're done. Okay, so here are a couple examples. So if you can try these or not, and then I'll do some examples, and then I'll tell you what the homework problems are, and then I'll practice those, and I'll do those as well. So if you want to stop the video, that's fine. Okay. So here it's the reciprocal function, right? So that means my horizontal asymptote will always be y equals 0. Okay. And then what you can do first is find that vertical asymptote is the big thing. So we have our horizontal, right? Y equals 0. So we draw that in there. Now to find the vertical, all we have to do is just set the denominator equal to 0. So there we go, x equals 0. It's right there. So I can go ahead and put that in, x equals 0, vertical asymptote. Here it's a little bit different, right? Here we have x plus 1, so that's going to move our horizontal asymptote to the left one, right? Because it's a plus 1, so we move the opposite direction. So at negative 1, there's our vertical asymptote, right? So again, what you can still do is set the denominator equal to 0 and solve for x. So x equals negative 1. So we see there's our vertical asymptote. Now, all you have to do is just really plot. You could plot the closest point, right? And you would go from, on this one on the left, you'd go from the origin, the closest point. So all I would do is take the absolute value of 2, not negative 2, because then I would get an imaginary number. So I'd take 2 and take the square root of that, right? And that would go from my origin, the intersection of my two asymptotes, and go from there. Or you can just pick a number to the right, say 1, plug that in. We get negative 2 over 1. And so it's negative 2. So I go down to 1, 2, plot my point. So there's my point. Now I can just come up, because you can plot in more points, but really all you need is 1. It's going to go up, and it's not going to cross that horizontal asymptote, and it's going to go down there. So that's that branch. You notice that this was negative, right? So that means it flipped it over the x-axis. Normally it was up here and down here. Now it's going to be flipped. That's why my blue one is correct, because it was a negative in front of the A. Okay, now I just need a point to the left. So I can do a point to the left, say negative 1. What's negative 2 over negative 1? That's a positive 2. So 1, 2. Again, now it's going to go up to the vertical and down to the horizontal. And there you go. So that's all you need really, is just 1 point. Okay, at least have 1 point. If you have more points, that's great. That's fine. Okay, this one. Again, I could take my a, square root it, right? square root my a, so square root 2, and figure out what that is, and then go from the intersection of here, go that many, and depending on what your a is. On this first one, it was a negative a, so that means I would do negative square root a, comma, square root a, right, and then positive square root a, comma, negative square root a to find my closest points. Here I have the positive, so all I have to do is take positive square root a, comma, square root a, and negative square root a, negative square root a, because I want to be in this over here, and I'm going to be down here. Okay. So, or again, you could just plug in numbers, right? Then you don't have to find the square root of 2, right? So I can plug in 0. So I can plug in 0 here. And 2 over 0 plus 1, that'd be 2. So that's 0, I'm up 2, plot my point. I'm going to go up towards this one because I can't cross this horizontal, right? And down towards the horizontal, can't cross it. So there's one branch, and I can get the other. Plug in negative 2, and negative 2 plus 1 is a negative 1 over 2. So I have 2 over negative 1 is negative 2. So at negative 2, I'm down to 1, 2. So I'm right here. So I'm going to go up and approach to the left, that horizontal asymptote, and go down and approach the vertical. So there's my graph, all done. So basically, I want to have the horizontal asymptote, the vertical asymptote, and then just one point on each branch. Okay, so here you go. Here's your homework, page 352, 17 and 19. F of x equals 2 over x. Our example was a negative 2 over x. And then 19 is 1 over x plus 2. So you can try these. Come back to the video if you need it. Okay, so here we've set our denominator equals 0, so that's x equals 0. Here we set our denominator equal to 0, we get negative 2. So those are our vertical asymptotes. We know because this is a reciprocal function, right? We have just a whole, we just have a number on top, an integer on top, divided by a linear denominator, right? So our horizontal asymptote for these type will always be y equals 0 because our denominator, degree of the denominator is bigger than the degree of the numerator. Okay, so then we can go ahead and graph these. Okay, so here we go. Here's our vertical asymptotes, x equals 0 and y equals 0 is our horizontal. Now we can again just start plugging in points. We can plug in a positive 1, we get 2. So it's going to go up towards the vertical, down to the right on the horizontal. That means this one is going to plug in a negative 1. Negative 1 is a negative 2. We're going to go to the left of the horizontal, down to the vertical. So you notice that the degree of this factor, right, my factor is just x on bottom, it has a degree of 1. So you notice that it approaches this vertical asymptote. One branch goes up, the other branch goes down. Same thing with this. The degree of the denominator is 1, and the degree of this factor, x plus 2, is 1. Right? It's a degree of 1. So this factor is x plus 2, and the degree is 1. So that's an odd number. So this should approach this vertical asymptote. 1 should be going up, 1 should be going down, or one might be going down on this side, and then this one would be going up. So it's always going to go opposite of each other, right? So an odd number, it's going to go opposite along the vertical asymptote. So let's go ahead and plug in numbers and see kind of what's going to happen. That fact kind of helps you out what to do when you have two vertical asymptotes, and we'll talk about that here in a little bit on the next video. So if we plug in numbers, say negative 1, so 1 over negative 1 plus 2, that is 1. So negative 1, 1, so I know it's going to go up. Oops, that was kind of bad. That's okay. And go down toward the horizontal asymptote. That means this one is probably going to go up this way and down this way, right? But I still want you to find a point, okay? So I still want you to find a point. You can plug in negative 3. So 1 over negative 3 plus 2, that'd be negative 1, right? So at negative 3, I'm at negative 1. So we'll just make this negative 1. We'll make that negative 1. So there you go. So there's how our graph looks, right? So that's it for this video.